Assalamualaikum and good morning, everyone.
Waalaikumsalam,
Waalaikumsalam,
teacher.
teacher.
Okay, so based on our last class, I have asked you to answer a few questions regarding the topic application of the definite integral. So today we are going to discuss the questions in this class. But first, I'm going to explain the learning objective. First, the learning objective is to find the tangent of the curve. Second is to determine the area of a region, and the third one is to apply integration to find an area bounded by two graph functions. So we will start the first question with Irfan.
Hi, everyone. The diagram on the right shows a part of a curve 4x equal to 4 minus y squared that intersects the straight line 3y equal to 18 plus 2x at point P. So the first question is to find the coordinates of the point P, and B is to calculate the area of the region A. Let's go to the first question. To find the coordinates of point P, we should know that point P is the point where the intersection happens. Therefore, we can easily equating both of the functions. Like how you can see here, you had to express both of the function in terms of x or y. And I chose y. And then you have to equating and rearrange the equation until you get the quadratic equations. After that, you just factorize the equation and you get the two values of y, which is 4 and -10. But I'm rejecting the -10 because, as you can see here, the point P is located on the positive side of y-axis. And you just substitute the y equal to 4 into any function, and you will get the x equal to -3. That's how you get the coordinates of the point P, which is -3, 4. Next slide.
I want to ask first, how can we confirm that the coordinate of the P is correct?
Thank you for the question. Since many of us are afraid that our answer might be wrong, so we can just substitute the coordinates into both of the function and see if the coordinate satisfies the function. And it is satisfied, then that might be correct.
Okay, thank you.
And the second question is to calculate the area of the region A. For this question, we are required to find the area of region A, which is bounded by the curve 4x equal to 4 minus y squared, straight line 3y equal to 18 plus 2x, and y-axis. You should know the trick where to find the area. We have to integrate the two functions with the same respect to any axis. Like here, I'm choosing x-axis. For this diagram, if you want to find the area by integration, you have to look at the diagram and identify which function is at the top and which function is at the bottom. So here is the function, is the straight line, is at the top, and the curve is at the bottom. So, and the formula is to integrate the function at the top, is to integrate the function at the top and minus or subtract the integration of the function at the bottom. And here you can see 18 plus 2x over 3 is a straight line function, and the set 4 minus 4x is for the curve function. And you just integrate them and you get 6x plus 2x2 over 3 times 2 minus with 4 minus 4x out of 3 over 2 over 3 over 2 times 4, -4. And then you just substitute the limit 0, 3 into the function and you get 17 over 3. For the limit, you can see here from the previous question where P is a -3, 4, and just substitute the limit. Yeah. Is there any question?
Can I find the area by using the integration with respect to the y-axis?
Yeah, sure. The answer will be the same since the answer will be the same, but I'm choosing the y-axis because there is already the limit here, -3. If you want to do the y-axis, you have to find the y-intercept here, which is which is it's much longer working to take lah.
Okay, thank you, Irfan. So we're going to move on to the medium question, Sarah.
So, for the example equation for the medium level, A, if the curve y equals to negative s cubed minus x squared intersect the curve y equal to negative s minus x cubed x squared at points -1, 0, 0, 0, and 1, -2, find the area between the two curves. Next slide. So, to find the area between the two curves, we first need to identify the point of the intersections and then integrate the difference between the two curves over the appropriate interval. As we know that this question already gives us the intersection points, that makes our work easier. So, we got two equations, and then we need to minus those two equations to make it simplify to make our words a little easier. Next slide. So for the interval -1 and 0, we just substitute these two intervals in equations, and then we just integrate it as the appropriate interval. And then when we substitute the -1 and 0 in the equations, we got the -1/4. So for the first region A1, the answer is 1/4.
I want to ask a question. So what do we have to do if the area is negative?
Since areas cannot be negative, so we take the absolute value.
Okay, thank you.
So for the next is we can find the area for the interval 0, 1. So as usual, as we did before, we just substitute the 0, 1 in equations, and we also got the area for the region A2 as 1/4. Next slide. And then, so the total area is...
Should we put the unit at the final answer?
Actually, it's not necessary to put a unit in the answer. But if you know the right unit, you can write it. But if the unit is wrong, the examiners will deduct your mark. So I continue my solutions. So we just need to add both two regions of area, and then we got the answer for all the regions between the two curves, which is 1/4 plus 1/4 is 1/2. So the area between the two curves is 1/2. So for the next questions, given that the curve y equal to x squared minus 4x and y equal to 2x minus x squared intersect at 2 points, so we need to find the area of the region between these two curves. As you know that the first step is you need to find the intersection points. So for these questions, the intersection points is not given. So you just need to find the intersection point ourselves. So at first we solve the x, and then we substitute the y, the value of x in the equation. So we got the y, and we got 0 and 3 for the intersection points. Next slide. All right. So thus the area is for A as integrate 3, 0, 2x minus x squared minus x squared minus 4x. So this is the equations for the area that we minus the upper and we minus the bottom limit, bottom equations. Next slide. And as usual, we just substitute the interval in equations and we integrate as usual. And we got 27 minus 18, and the answer is 9.
Okay, thank you, Sarah. So I'm going to explain the hard question here. So we have the question sounds like this. Find the equation of the tangents of the curve y equals to 6x plus x squared at the origin and at the point x equals to 2. And given that the two tangents to the curve intersect at A, find the coordinate of A, then find the enclosed area by the tangent and the curve. The first question stated that we need to find the equation of the tangents. And they give us 2 points here, which is the origin and also x equals to 2. So there are two tangents for this question. using the formula of the tangent line here that I have put inside the slide here, first we need to find the gradient of the tangent. If the derivative of the curve, so dy dx equals to 6 plus 2x. For the first tangent line, we just need to substitute the coordinate of the origin, which is 0 and 0. So we will get the first tangent line is y equals to 6x. And for the second tangent line, we get the point x equals to 2. We need to find the y value first. So we just substitute into the curve formula and we will get y equals to 16. And after finding out the coordinate of 216, we just put it inside the formula of tangent line to find the second tangent line. So the second tangent line is y equals to 10x minus 4. For the second question, we have two things that we need to do here. First, we need to find the coordinate of A and then find the enclosed area. To find the coordinate of A, we can see here, I have visualized it into the graph. And A here is actually the intersection of both tangent lines. So we just need to equalize both of the function for tangent line, which is x minus 6x equals to 10x minus 4, and then we get x equals to 1. Y equals to 6. So the coordinate for A is 1. For the second question, we need to find the area. So firstly, finding the area, we need to find all the intersection first to determine the interval of the area. For this question, we only have the intersection for A. So we need to find the intersection of this line, y equals minus 4 and the curve. So using the same method, we equalize both of the equations. We will get the coordinate for this one, I call it as B, is 260. After that, proving which one is the upper, which one is the lower equation. So from the graph here, we can see that the upper equation is the curve equation. So we will put the 6x plus x here, and the interval is 0 until 2. And then we need to minus the line 6x with the interval of 0 until 1, and minus the integration of 10x minus 4 from the interval 1 until 2 with respect to x. We just solve it and we will get the answer of the area is 2/3 units.
Teacher, instead of using the graph method, what arithmetic can we use to determine the upper and lower equation?
Okay, thank you for the question. So if the equation given is hard, what we can do is we find all the intersection for all the lines that are given. Because if we use the intersection, we can actually determine which one is at the top, which one is at the bottom, or which one is at the left, or which one is at the right. So we can actually guess which one comes first before the others. The second method is using intersection.
I do have a question, teacher. Is it easier to integrate it with respect to the y-axis?
Okay, so if you look at the graph here, it's really difficult to integrate it using y-axis. We can do it, but it is hard because even though we have the interval here, 0 until 60, but we're not sure whether which one of the line is actually the right one, which one is actually the left one for us to subtract that. So it's easy for us to use the x method because with respect to x, make sure that we don't take too long to answer the question. You understand, right?
Yes.
So for all the questions that we have done today, the references are as below. If you want to check for more questions, you can go and search for this reference, okay? And
Teacher,
Last, thank you for everyone's cooperation, and we will meet again at the next one. Thank you.
Thank you,
Thank you,
teacher.
teacher.